Hello everyone, welcome to Embedded Systems course with Arduino. In last session, we had interfaced a DC motor, a direct current motor to Arduino through and slide switch, right? In today's session, we are going to interface another type of motor which is known as servo motor to Arduino. So, what is the difference between DC motor and servo motor first, right? So, DC motor in general, right, it has high speed but it has low torque. Okay, now it doesn't have control over angles at which you rotate, right? It rotates around 360 degrees, but you don't have a precise control over the angle at which it will rotate. But servo motor is useful in those cases, right? So in your elevators, in your radars, in your RC planes, radio controlled planes or cars, these servo motors are used widely, right? And even in angular controls of robots and all, hands and all that, these servo motors are used widely, right? So servo motor, right, has low speed but it gives you high torque. Okay, now this is in general the design of the servo motor which you get in market. So you see here you have a 0 volt connection to the ground, right? You connect the ground pin to 0 volt, you connect VCC to 5 volt, and there is a control signal, right? If you want to control the servo motor through Arduino pins, right, so you have to connect that pin to this control signal, right? So here this servo motor rotates from 0 to 180 degree. Okay, so and there is a precise control which you have at what angle you want to rotate. Okay, so this is the benefit of servo motors, right? And in general these servo motors can be directly driven from Arduino, because this current servo motor which you are seeing drives very less current. But even if you drive currents greater than 300 microampere, right, or milliampere, then you should use direct voltage supply, okay, to the ground, and the this power pins. Okay, the VCC and the ground pins you should directly connect from an external power supply. Okay, so now let's go over to the actual functioning of this servo motor. How can you control the angles at which the servo motor can rotate, right? So if you are able to see, the angle of rotation of the servo motor is controlled by the pulse width modulated signal which is provided to the servo motor. So what is PWM? PWM stands for pulse width modulation. Okay, so as you can see in the diagram below, right, this is a frame where you see the animation, right? So as soon as you see that the width of the pulse is decreasing, it is 0 degree, and then it keeps on increasing to 180 degree as soon as the pulse width increases, right? So if you see, the pulse width will increase now and it will go to 180 degree, right? So this is what controls the angle of rotation of the servo motor. Now the question is that how can we provide these PWMs signals, right? So in Arduino already there are pins, right? So pins with tilde symbol, right? You will see pins, digital pins, and below that there will be a tilde symbol. So those pins are PWM pins. But is it necessary that all pins cannot be connected to the control pin of the servo motor? No, it's not correct. You can connect all digital pins to the of the Arduino to the servo motor control pin, right? But how to do that, right? For that, Arduino has provided some inbuilt libraries, right? Right, like we saw libraries for keypad, LCD, etc. We also have libraries for servo motors. So once you include this library in your C++ Arduino code, right, you can the object created of this servo type can access any function and the functions include setting the servo motors the angle of rotation at a particular angle, right? So in your C++ code, right, in the Arduino you include this library servo.h. Once you have included, you create an object, right, of you create an object of servo type, like say, let's say servo my servo, right? So this, for example, is an object, right? This is your object, my servo, which you have created. Now this my servo can access the inbuilt functions. So what are the inbuilt functions which are widely used? One is this attach, my servo dot attach, if you write, right, and the pin number. So pin number is what? Pin number is the pin of the Arduino, right? Arduino digital pin which you are connecting, Arduino digital pin which you are connecting to the control pin of servo motor, right? So this can be any pins, okay? You can connect from 2 to 13, you can connect any of the pins, and once you attach this, it makes sure that you are able to drive a pulse width modulated signal to that control pin of the servo motor from the connected Arduino digital pin, right? Now what is this angle? So you can put here 0 degrees to 180 degree, any value you can put, right, in this parameter, right, and the servo motor will rotate to that angle, right? So you have a precise control at the angle at which you are rotating, right? And if you want to read the status or read the status of servo motor at what angle it is currently located, so you can use this read function, right? So these three inbuilt functions can be used once you have created an object of servo type, which you can do by including this library. Okay. So this is the library function which we'll use in our code. So let's go over to Tinkercad and start creating this simple embedded circuit where we will connect a servo motor to Arduino, right? So the components which we will need, right? Components in general which we will need for today is we'll create a simple circuit. So we will need Arduino Uno R3, right? Then we will need a servo motor, right? So in Tinkercad you will get it as micro servo. If you search like this, you will get it micro servo motors, and of course you will need a breadboard, right? Now you can also, rotate the angle or of the servo motor through a potentiometer. You vary the potentiometer is a variable resistance, so you vary the resistance and your angle of rotation will change. But that circuit connection we'll see in the next session. Today we'll create a simple circuit where we interface a servo motor to Arduino and we'll do the breadboard connections. Okay, so let's move over to Tinkercad. So we'll go over to Tinkercad, right? And we will create a circuit, right? Click on create, select the circuit design, right? And once you will click on this tinker this, right? This white space will occur, right? So what I have taken is I have taken a breadboard, I have taken an Arduino, and I have taken a servo motor. So let me show you in the components. If you click on, if you search for servo, you will get it as micro servo, right? So this is your micro servo motor, right? I can delete this, right? I have already taken one, right? So this is your micro servo and the type is positional. Okay. So now what we do is, as usual, the basics first. So we'll connect the ground pin of the Arduino to the negative row of the breadboard, so that this row is now at 0 volts, connecting the same above negative row to 0 volts. Similarly, we take the 5 volt pin, the red wire, connecting this to the below positive row, providing this at 5 volts, and similarly applying the 5 volts to the above row, right? So this row is now at 5 volts. Okay. And now the servo motor connections, right? So servo motor connections are very simple. There are just 3 pins. If you see here, what is this? So this is your ground. So we connected the ground to the ground row, right? This is now at zero ground volt, 0 volts. Now you have a power. So 5 volts are connected to this, right? And now what we will do is, let's take the control pin of the servo motor and connect to, let's say, pin number 9, right? But I told you, see, you see a tilde symbol here, right? So all these pins are PWM pins, can drive PWM signals. But once we include the servo library, you can also attach any other pin which is not PWM to the control pin of the servo motor, and that drives a PWM signal, the pulse width modulated signal you saw in the animation, right? As and when the width of the pulse changes, right, the angle at which it rotates changes. So now what we have done, we have connected the control pin of the servo motor to the ninth digital pin of the Arduino, right? So the circuit connection is done, very simple circuit connection. Now let's go over to the code, right? So I included the library servo.h, right? This is the library from which now you can create an object of servo type. I created an object servo1, right, of the servo type. Now create, just taking a variable angle, so that I can change this variable, right? Now one time connections we need to do in the setup task. So what I do, I attach now pin number 9 we attached, right? So let's change to pin number 9, right? So now this attach pin will connect the pin number 9 to the control pin of the servo motor, right? And you can drive, or you can control the servo motor angles through Arduino through this pin, right? Now what we can do is, so now in the loop function we want to rotate to particular angles. So in this what we are doing is, the task is to rotate it from 0 to 180 degree, and then in the reverse from 180 degree to 0 degree. So what we are doing, we are taking this angle variable, looping it from 0 to 180 degree, right? Writing a for loop and writing the angle through the servo1 dot write. Servo1 was an object which we created. Write is the inbuilt function which you are using, providing the angle in that in that function as a parameter, right? So it will set 0, 1, 2, and then we are waiting for 20 milliseconds, giving 20 milliseconds to the servo motor to get to that angle or get to that position, right? So this will happen till 180 degree is reached, and then we are reversing it from 180 degree, we are asking it to go back to 0 degree, right? Same way, right, using the right inbuilt function of the servo library and providing a 20 millisecond delay now, so that it reaches that angle. Now if you increase this delay, it will take much slower time, right? So by this you can control the speed, right? So if you provide 200, it will be much slower, right? And if you provide 20, it will be faster. So we'll see that impact. So now let's start running this. If you see, it's rotating, right? So 0 to 180 degree, right? And then 180 degree to 0 degree. Okay. So this is 0, and once you start this, what happens? 180 degree it will rotate, and then from 180 to 0 it will rotate. Okay, now I'm stopping this. I am just delaying this. Okay, I am controlling the speed. Let's say I put it as 200. 200 will be very slower. We can try putting it 200. We can see one swing complete. Let's see. See, it's rotating very slowly, right? So this is because you have asking them to set the angle to 0, and then you're giving sufficient time to land to that angle, right? So it's taking very slow time to even turn to 180 degree, right? Now let's make it a bit faster. I will stop this simulation, right? I will take it 100, right? And I will run this. Let's see the impact, right? Now see, this is a bit faster now, right? Compared to 200. You have to wait because we have slowed down the speed, right? So this is how you can control the speed. Now let's, right, let's make it 50. Let's make it faster. So see, right? So you are able to control the speed in this matter. You are able to control that angle, and servo motor provides you that feature, right? So it's very useful in real-time applications, right? If you want a precise control over angles, the servo motor can be used in this way, right? So just the coding wise is very simple, including a servo library, creating an object, and then using the inbuilt functions from the library, right? So this is how you can create this servo motor or interface a servo motor to Arduino. Okay, in next session we will control this rotation using a potentiometer or using a variable resistance. We'll design that circuit in the next session. Thanks for joining.